Thanks, Laura. Good morning, everyone. On behalf of the EAGLE program, Eliminate Aviation Gasoline Lead Emissions Initiative, thank you for joining us this morning. I'm Kurt Castagna, President and CEO of NATA, the National Air Transportation Association, and it's my privilege to serve as the industry co-chair for the EAGLE initiative. EAGLE is an FAA industry coalition dedicated to the elimination of leaded aviation fuel by the end of 2030, to be carried out in a safe, smart, and coordinated transition without adversely impacting the existing general aviation fleet. The EAGLE industry partners represent all aspects of the general aviation ecosystem, including general aviation manufacturers, airports, FBOs, aviation fuel companies, commercial aircraft operators, rotorcraft operators, aircraft owners and pilots, and experimental aircraft home builders. When EAGLE was formed in February of 2022, these national partners joined the FAA in agreeing to 4 key objectives: facilitating stakeholder support for development and deployment of viable unleaded fuels, developing technical solutions to mitigate impacts on the existing fleet, informing regulatory processes and policies to safely and smartly eliminate lead emissions, and protecting the availability of 100 low lead during the transition. FAA reauthorization legislation that was enacted last year made great progress toward that 4th goal by requiring publicly obligated airports to maintain access to 100 low lead through the end of 2030 or the end of 2032 in Alaska. Although we continue to see state and local actions attempting to prematurely outlaw the use of leaded avgas without a commercially viable replacement fuel, EAGLE's work has helped steer those attempts towards the 2030 timeline, and as an organization, we will continue to do so. Recently, we've begun to see STC fuels entering the marketplace, mostly in California, where there's a strong environmental focus. Clear communication on FAA processes and coordination with industry have never been more important from our perspective, and the work of EAGLE has never been more relevant, even as we transition to a new administration in Washington. I'm joined today by industry colleagues from the National Air Transportation Association, NATA, the General Aviation Manufacturers Association, GAMA, the Aircraft Owners and Pilots Association, AOPA, the Experimental Aircraft Association, EAA, and the Vertical Aviation International Association, VAI, all of which will provide technical updates and answer questions on EAGLE's progress towards our mission and key goals. I'd like to turn it over now to Rob Hackman from the EAA, who will highlight the key elements of a viable replacement fuel and the process of a national transition.
Well, thank you, Kurt, and everybody, appreciate everybody joining us here on Saturday. If anybody's interested, drinking Tim Hortons coffee for coffee with this morning. So hope everybody has a good cup of coffee on their end. This is our agenda today. We're going to go through a lot of information in this time and hopefully leave some answers for questions. So hopefully we get to all of your questions today. If not, as Laura mentioned, please feel free to send them to the information at the end via our EAGLE website. So that'll be up at the end during the Q&A. So with that, Kurt mentioned we're working towards a viable unleaded replacement for 100 low lead. What does a viable unleaded replacement mean? It may mean different things to different folks, but first and foremost, it has to ensure safety. We have to maintain the safety for the engines and aircraft as we transition to any new fuel. That needs to be paramount, and it needs to be a fuel that is acceptable for use in the industry. Part of that also has to take into consideration the production and distribution of the fuel. This has to be a solution that works across industries for the petroleum producers, the supply, distribution, the end users, consumers, and the like. And for the consumers, a big part of that obviously is the economic consideration of any new fuel. Not just cost per gallon, but what does it cost to transition to the fuel? In order to do that, we need to make sure that we have good stakeholder involvement and stakeholder understanding of any of the new fuels. Also needs to include all the users, flight schools, fleet operators, and the like. And our manufacturers, our OEMs, our aircraft engines and airframe manufacturers need to have a good understanding of the fuel in order to be able to support new production, to be able to support technical questions that come up, and warranty issues as well. So those are some of the key concepts that go into determining what is a viable, or how we define a viable and unleaded replacement fuel. To give everybody kind of a visual as we get into this, we're going to go into a lot of detail into each of these sections, but this is a kind of a visual presentation of what we're talking about and what the pathway that we're working on to undertake this. It all starts with the fuel developers. The fuel developers are the key to seeing what new fuels are available to us. The FAA provides two different pathways for fuels to become authorized to be able to use in our aircraft. And we're going to spend a lot of time on both of those pathways today and give you updates specific to each of the fuels that are pursuing these pathways. The first pathway is the fleet authorization pathway. This came about in 2018 in the FAA reauthorization bill, where it actually authorized the FAA to issue fleet authorization without an applicant for a new fuel's approval. This realized that new fuels coming forward may be coming from sources that were not traditional, that were traditional to the certification process, so fuel producers and the like. So this allows the FAA effectively to be an applicant. It relies heavily on the PAFI testing, or the Piston Aviation Fuels Initiative, which you'll hear more about here in just a second, and also the industry consensus standards process, the ASTM production specification, to get the peer review for the process. And that results in a fuel being issued a fleet authorization. And we'll talk about what that means to each aircraft owner and the maintenance folks that are here. The second pathway is the traditional pathway, the existing type certificate pathway. In this case, a supplemental type certificate as a change to add a new fuel to aircraft. This relies on the STC approval process, which is a proprietary process agreed upon between the FAA and the applicant. And again, more detail on this to come. It relies on either an ASTM production specification or an independent specification developed by the company. In either case, the specification has to be accepted by the FAA as a part of the STC approval process. And this results then in a supplemental type certificate. What we're seeing is what is called an approved model list supplemental type certificate. So instead of an STC issued for each make model, it's a large approved model list that includes many airframes, many engines. So an STC for both the engine and then an STC for the airframe itself. From there, we get into the owner-operator and the approval process. In either case, the fleet authorization or the STC pathway, both result in something that needs to be installed on the aircraft. In the case of the STC, most folks are familiar with installing an STC onto an aircraft. Whatever modifications need to be made as a part of that STC, including manuals, aircraft manuals, fuel placards, those types of things. You're purchasing that STC from the STC holder and then installing it per the directions. In the case of the fleet authorization, you will also be installing that authorization. Similar, it will include fuel placards, will include flight supplement manuals for the new fuel and any other modifications that need to occur. In this particular instance, the FAA will be issuing it. You will not have to purchase it, being one of the main indications. In both cases, any aircraft modifications that need to be considered are a part of those directions. In the case of the fleet authorization, there will be additional information that is provided for the experimental amateur built community in order to provide information to help the experimental amateur built community transition to a new fuel. A key component, as we mentioned before, in determining a viable fuel is ensuring that the production and distribution is also considered throughout this. So as this is going on, as the development of the fuels are going on, as the authorizations of the fuels are actually being worked through, producers and distributors need to be a critical component of this. In the fleet authorization pathway, they are a part of the group that is developing the test methodologies, the PAFI testing and the like, and are kept in the loop through the ASTM process, as well as the ASTM production specification is developed, balloted through the process. So the producers, distributors, FBOs, and like are kept informed as to progress that's being made and information about the fuel development. In the STC pathway, still critical that that happens, but it relies on the STC applicants who are working with proprietary information between the FAA and the applicant to keep the producers, to go out and get the producers informed, the distributors informed, and the FBOs informed. So one is a bit more of an open and collaborative process. One is designed to be a bit more of a proprietary process that's in play. We have one fuel that is working through the fleet authorization pathway that we'll have an update on today. That's the Lyondell, Basell, and VP Racing fuel. We have two fuels that are working through the STC pathway. That is GAMI, General Aviation Modifications, Inc. That has been issued an approved model list STC, and Swift Fuels that is also working through the STC pathway. They also have been issued a limited STC and have some limited fuel in the field as well. So updates to come on both of those. As this is working through, at the bottom there, you'll see the EPA endangerment finding and the EPA regulatory and rulemaking process underway. As most folks, I think, are aware, the endangerment finding has been issued. So now we're working through any potential or future FAA and EPA rulemaking that will come out of that. And we are anticipating that over the next few years. We are working collaboratively with the FAA through the EAGLE process, and they in turn are working with the EPA as it moves ahead. So that's intended to give an overview of the process, kind of a visual that you can kind of keep in the back of your mind. At the end there, once the approvals are issued and installed on the aircraft, and again, we'll talk a little bit about what the responsibility for the maintenance in the field is for that. Obviously, the last thing is a strong continued operational safety environment as any fuels enter into the field to ensure that we're addressing any issues that arise out of that. So that's a key component. We're going to spend the next 45, 50 minutes here going into some detail here on each of these. I think that's what a lot of you are actually interested in. The first thing we're going to talk about are those two pathways and what some of the key differences are. And I'm going to bring in Walter DeRozier from Gamma, who's going to join us, and he and I are going to tag team a little bit here on the various fuels. Walter, what are you drinking this morning? What coffee?
All right. Well, good morning, everybody. I am originally an A&P mechanic, so my focus is on high-leaded, high-test coffee. So I drink a dark roast Starbucks black coffee, no sweetener added. But good morning, everybody. Welcome, and I appreciate the opportunity to kind of walk through and talk through some of these issues with you. So Rob talked about on the big picture chart the different pathways by which you can obtain FAA's approval or authorization in order to use a new fuel. And one of the things to highlight is, the FAA's focus and emphasis is on the safety of the engine and the safety of the aircraft and ensuring that they continue to meet all the applicable airworthiness requirements for those. So as part of those processes, that's what the FAA is focused on. There are two pathways, as Rob said. One is the supplemental type certificate process, traditional process on how we do all of our modifications and alterations for major change on aircraft through the type design process. As he mentioned, there are two applicants. I'll talk a little bit more of their status and where they are on that, going through that process. The second one is relatively new and unique to fuel. Congress passed authorization allowing the FAA to recognize that in this area of fuel, most of the expertise, all of the development is done by the fuel and petroleum and chemical companies in industry, and they're experts in that field, but they are not product development and aircraft certification experts with the FAA. And so there was kind of a gap in terms of the ability for them to invest in the development of some potential candidate fuels that could be considered for use in engines and airplanes. But at the same time, they do not have the expertise of FAA certification, would not be making application to the FAA to obtain any kind of a type certification approval. And so we wanted to make sure that in order for them to invest in the development of fuel, that they had a pathway to market. So without the FAA approval, cannot be used in the engines and airplanes. There's no pathway to market. And so what Congress did is establish a recognition that the FAA could have a fleet authorization process. It ensures the same exact level of assessment and review for data to be generated and to meet all the applicable airworthiness requirements of the engines and the aircraft and all the safety requirements. But in that process, it was a collaborative FAA and industry approach on doing the actual certification testing, certification evaluation, and then the determination and issuance would be done by the FAA and would be made available publicly for free by the FAA. And so the applicant that's currently going through that process is the Lyondell Basel VP Racing Fuel, pursuing the development of a fuel through FAA fleet authorization. So in that process, Rob mentioned that a supplemental type certificate is just like every traditional type certificate process under the FAA. It is a proprietary applicant working directly with FAA. They make application just like a traditional manufacturer does. Gamma members that make Cessna airplanes, Lycoming engines, they make application directly to FAA. Those are proprietary activities where they engage. The traditional certification process requires that the applicant show compliance to all the requirements necessary for safety to meet the airworthiness requirements, for example, Part 23 airplane, Part 33 engines. But the applicant controls that visibility of all the required tests, all the evaluations, all the assessments that they do to show compliance. FAA does their traditional certification process and they review that documentation and they determine and make a finding that the applicant has shown compliance to make its determination to issue the FAA design approval, whether it's by TC, amended TC, STC, or in this case, the AML STC. The applicant then can choose and control the visibility of all their data, what testing they did, how they showed compliance. That is all applicant proprietary data that they decide how they want to share and communicate and how they can provide visibility to that. Likewise, if they're using a company specification as part of their STC, this is the independent specification, then the applicant controls the visibility and availability of that as part of their design approval. The second pathway where the FAA does a fleet authorization process through the collaborative industry and FAA Piston Aviation Fuels Initiative, that is purely a testing program. So PAFI is just a testing program coordinated and in coordination with all the aircraft and engine OEMs and many stakeholders in developing the envelope of different tests, the envelope of different assessments, how they're going to basically generate the data necessary to show compliance to all of those airworthiness requirements. In addition, PAFI, because it comprises the broader range of stakeholders, is also looking at other stakeholders beyond just the airworthiness requirements of engine and airplane. It includes other stakeholders such as in the development and distribution of fuel, in the storage and transportation of fuel, the FBOs in terms of the ability to dispense fuel, and then in the operation of that fuel. And so there are many additional elements identified through the joint industry and FAA test program that go beyond what is the engine and aircraft certification to include other areas. And we'll get through and show that in more detail. So that envelope of the test program that was developed under PAFI is available on the flyEAGLE.org website. It does provide the list of materials, the envelope of different engines that are being used as a basis for the testing, the aircraft, and we'll show a little bit more detail on that. We think it's also important to understand, and there's been a lot of media and discussion about what is ASTM and how does that contribute. So the ASTM is a consensus standards process. It is the industry's process. It is not required by FAA or by government. It is an industry voluntary approach in terms of how we manage and control and support the commercialization of fuels. In fact, it is the custom and practice for all transportation fuels that are widely out in the market today, used in aviation, used in the automotive industry, used in the marine industry. All fuels today have gone through the ASTM consensus standards process in terms of establishing a specification with the coordination and cooperation through the stakeholders. It does support the commercialization, as I said. It's the production, distribution, and use, but it is not required for FAA approval. And so today we do have, when I talk about the individual fuels, Next slide.
Hey, Walter, before we jump to the next slide, I think what you articulated there is worth repeating real quick. The STC process, as it's laid out here, is not anything new or different for the fuels aspect of this. It is the existing STC process used for anyone introducing a new radio, a new engine onto an aircraft, those types of things, or developing those. So that proprietary process is not new. It's not specific. It is the existing process that's in place. It relies heavily, though, on the expertise of the applicant and the engineer for the FAA that is working the program to develop between the two of them and agree upon the appropriate testing procedures, the data that's developed and the like to be accepted and to be able to put forward. Whereas the PAFI process established by Congress gives us a different approach whereby we brought the industry in to determine what's the spectrum of engines and airframes, worst case scenarios depending on the fuels, or the envelope, edges of the envelope that need to be looked at. And those groups agreed upon what the testing protocol should be for the new fuels to determine the data that's brought forward. And then the data is evaluated in the ultimate peer review process through the ASTM consensus standard. So just articulate what you said there so well is just that there are two different approaches with the same end goal of fielding safe and viable fuels.
And Rob, I think that's a great clarification. The traditional certification process that the FAA has, which is for type certificates, amended type certificates, and supplemental type certificates, is how all of the fuels that all of our engines and airplanes are qualified and approved for use today. The original 8087, the 100 low lead, all of those were tested and evaluated and authorized and approved through the traditional type certification process. Now, each of those were also tested on every individual make, model engine through its respective certification process, through every individual make, model aircraft as it went through its certification process. So what's a little bit unique here when we look to go backwards and retroactively say, how do I look back at all these engines and airplanes already certified when they all did testing individually and find a way to test a new fuel that could be eligible and equally safe for that scope of engines and airplanes.
And the only time that we used the STC process from a fuel standpoint widespread was the introduction of autogas, and that was for a portion of the fleet, not for the entire fleet.
And UL 94 has an STC approval as well. But manufacturers also do approval of new fuels through their respective processes as well. So one of the elements we also wanted to talk about, it's not just about the test and evaluation and the authorization and approval of the FAA for the fuel itself to be used in engines and airplanes. One of the important aspects is the importance of it being installed on the engines and aircraft that it's intended for. And so again, this is an important part of the FAA's traditional process in terms of ensuring the continued safety of the fleet. And so for a fuel that is approved and authorized through the traditional certification process, an AML STC is issued for the fuel. Every AML STC or multi-model STC does include a limitation in it. The limitation is the installer must determine whether the design change is compatible with previously approved modifications. Now, the reason that's important is as part of the type certification process, you have to have a known configuration that you're assessing and evaluating. So when they did the STC, they evaluated the base configuration of a T-seat engine and a base configuration of a T-seat aircraft and determining that it would be eligible and safe to operate. It is not possible to take into consideration how many different independent third-party modifications and changes might exist out there. And so the original STC as issued is only going to focus on the base configuration. So this is standard method and mechanism for installing changes on an aircraft. AC 2188 prescribes some of the guidance and the approaches to help support the ability to install changes and modifications to an aircraft. And so AC 2188 is titled The Compatibility of Changes to Type Design Installed on the Aircraft. It goes through some guidance on providing an understanding of how you make an assessment of the approved STC and whether it's compatible with other changes, other STCs that might have been made on that engine and airplane. Likewise, as part of that installation, it's installed as a major alteration to the aircraft. There's a Form 337 that's completed. The AC 43.9, which is the instructions for filling out a 337, does walk through the different methods and the boxes and the information to be provided in there. But in terms of, it says that the form serves three main purposes. Obviously, to provide the aircraft owner and operator with a record of the major repairs and alterations made on their aircraft. It also provides a record to the FAA as they're submitted. But then the third one that it outlines in the AC is it documents and records the compatibility assessment conducted by the installer. So it reinforces the importance of that. So when it comes to fuel, there are many modifications and changes to an aircraft that wouldn't have any effect whatsoever on the eligibility of an STC for fuel to be put on an airplane. However, if you have an STC that does impact anything in the area of how the fuel in the combustion of the engine, you have changes that might change compression ratio or power, or you have changes that might affect the timing. All of those are a direct impact on the airworthiness of the engine to be able to operate on a new fuel, because that new fuel may not have been assessed for an engine that has a different compression ratio or an engine that has a different timing set for it, or if an engine in aircraft configuration has different cooling methods that are being used, or if there's a change in the fuel system and the materials in the fuel system. So anything that directly impacts the performance of the engine, anything that directly impacts the materials that come into contact with the fuel would then be assessed for compatibility. And so that's what the AC does, provide some instructions for that, as well as the installation instructions from the STC could also provide additional instructions in detail to accommodate that.
And that's to say, Walter, that a modified aircraft with multiple STCs, it's not that it's not that it can't run on the new fuel. It's just that there's different considerations and additional things that need to be taken into consideration before that determination is made, and that falls to the responsibility of the installer to assess those and to do that, which is similar for my experimental amateur built community that I represent as EAA. For us, the STC does not directly apply. We're not type certificated aircraft, so a supplemental type certificate, a change to a type certificate, doesn't directly apply. The responsibility and decision is going to fall to each owner operator, as it does for most modifications. And many of the same things that Walter just talked about, we're going to need to take into consideration with regards to whether our aircraft are safe to run on this new fuel. Materials compatibility will be a big one. We had an article back in November that talked about knowing the materials on your aircraft, but also engine modification. So we may have what is a traditional type certificated engine on our experimental amateur built aircraft. There may be an STC that gives us an idea or gives us a level of confidence that the fuel is safe to use. But if you've modified the engine, electronic ignition, bigger cylinders, that type of thing, you have additional work to do to ensure that it's safe to operate before you operate on the new fuel. And that's some information that we're hoping that the fuel sponsors are putting out, the engine modifiers are putting out, that we will be putting out additional data to help make that decision is what we want to come up with.
And AC 20-188 does provide some guidance in terms of, as part of that assessment and looking at those differences, is also a determination of how you get the appropriate data to support that change. So
Now,
those will be done by field approval or by some kind of a minor or major alteration. However, if it rises to a certain level, it might require an additional STC or a change from a type design perspective.
Now, the fleet authorization is envisioned to provide a bit more information and perhaps provide additional input for these folks.
So thank you for that. So I talked about how there's a broad industry NFA engagement in the developing the data as part of the fleet authorization. So that data is generated, encompasses a lot of information, and it supports two things. Fleet authorization does require an ASTM specification. So that way the data is generated and it provides support for those reports to be reviewed by all the stakeholders in the consensus standards process of ASTM. And through that process, the peer review will provide additional input and understanding on the fuels might request additional data to be generated or substantiation and understanding to be generated. But as part of that process, the FAA also uses all of that data that comes out of the PAFI testing and that comes out of the ASTM consensus process and the peer review process to make its determination on aircraft engine and the aircraft and engine eligibility. So what the FAA will do once they've determined that they have a viable replacement fuel based on all the PAFI testing, based on the ASTM consensus process and stakeholder support and approval of a production specification for a new fuel, the FAA will then generate, it's based on all that data, just like an STC, determine the applicability of all the airworthiness requirements for the engine and the aircraft to be meet the safety requirements. They will then issue an eligible fleet authorization summary report. That's a document that's going to provide, kind of like an AML STC, it'll provide all the eligible engines and aircraft. It'll provide detailed installation procedures and instructions, plus additional information. So for example, Rob mentioned that a traditional STC would only apply to type certificated engines and aircraft. As part of the fleet authorization process, the FAA does have a lot of extra data. And in the form of that data, they're going to make that available in that report. And it's going to include, for example, the availability of data to support some of those aircraft that are not type certified, such as light sport aircraft, experimental aircraft, but it'll provide them the data that they need to be able to support their ability to assess and determine eligibility of their own aircraft, which are not type certified. In terms of how the FAA would deploy that and make it available, because it's different than an STC, they're going to issue an SAIB. So the SAIB is going to then provide notice of the fuel that has been authorized and approved by the FAA. It'll provide notice of the information, not only the eligibility fleet authorization summary report, but any additional information and guidance necessary to support the ability for the installation of the fuel, modification to engines and aircraft, and then alterations and use in the fleet and in the field. So as an example, it will talk just like an STC would about how you make your determination of eligibility, how you make your determination of compatibility with other changes to the aircraft. How do you install the change on the aircraft? For most engines and aircraft, the expectation is it would be once they determine to be eligible, it'll be a change to the flight manual as a supplement, because there's a limitation on all engines and aircraft today that you can only operate using the known or authorized or approved fuel. So this would give you a supplement, adding an additional authorized or approved fuel that you can use to put into your flight manual, and then also change the placards and the decals on the aircraft, indicating the appropriate fuels for that aircraft. One of the things in terms of enabling and facilitating a transition is all of the fuel developers today, all of the FAA testing and assessments today are to completely commingle with 100 low lead. And so that really makes enabling the ability to transition fuels, to enable an operator to pick up fuel at one location and go to a different location that may not have transitioned yet, is the complete commingling capability with between 100 low lead and a high octane unleaded fuel. Today, each one of those is being done individually between the fuel and 100 low lead. All of this process for the installation of a fleet authorization fuel has been published in an FAA policy document. It's PS Air-600-20-01. It's kind of the small picture on the right-hand side there, but that lays out and describes the detailed process by which the FAA has put into policy on how a fleet authorization, which is new and different and unique to this fuel, for these new fuels, can be used in the field, and the instructions for the field on how they get determine eligibility, determine installation, and deploy in the field.
Very good. So Walter, we're going to move into the next phase here, where we talk about the fuel applicants and give an update on each of the three. And again, just as a reminder to everyone, we have two fuels that are working through the type certificate or supplemental type certificate process. GAMI with their G100UL and Swift with their 100R. And then we have a fuel that is working through the PAFI fleet authorization by the FAA, which is the VP Racing Lyondell Basell VP Racing fuel. So we're going to give an update here on kind of the status of each of these three. So we'll move into that.
So I'm going to start with the STC fuel. So as Rob mentioned, GAMI has obtained a STC, AML STC approval and authorization for the use of G100UL is their trade name for that new fuel. The current STCs that have been issued, you see the STC number on the screen there. But for every fuel, there's going to be two approvals needed. You need an approval to change the limitations on the engine, authorizing it to use a new fuel, and you need an approval to make a change to the aircraft limitation, authorizing the use of a new fuel. So there are two AML STCs that have already been issued to GAMI. They are very broad in terms of a fleet. The Part 33 engine AML, the way it's been reported is it basically includes all spark ignition reciprocating engines. So I haven't gone out there and done a side-by-side comparison to every single type certificate the FAA has ever issued, but it is a very, very broad AML STC in which GAMI has shown to the FAA that they've got the data that helps support that, and the FAA has issued that STC. The second STC is the Part 23 AML STC. That is for the fixed wing Part 23 airplanes, and it's a very broad AML STC for that. We do know that GAMI has application and a certification project underway with FAA today, looking to add an additional AML STC for rotorcraft. So for piston powered or spark ignition piston powered rotorcraft. So that STC project is ongoing. Another important thing about GAMI with their STC approvals and authorizations to be used in fixed wing airplanes, they have been looking to try to market and deploy out in the field. They've got a partner in VTOL Aviation, which is a large oil company and producer of various fuels. And they've decided to support and participate in partnership with GAMI and produce their fuel. They reported at Sun and Fun in a press conference that they have 1.3 million gallons that they produced for them and are going to make available to deploy. GAMI has announced and done projects at a couple of airports, which have publicly talked about the fuel being available today. So Reed Hillview in California has the GAMI fuel available today. Watsonville, California has the GAMI fuel. And more recently, they've had some public notices announcing availability in Tupelo, Mississippi for the GAMI fuel. So in terms of what was tested, how it was tested, as I mentioned earlier, as with every type certification project with any applicant, it is all proprietary between the applicant and the FAA. And so there isn't a lot more that we as stakeholders in the EAGLE program can report on the details other than what they've made available. So right now we do not have a lot of additional information in terms of how and what was tested and evaluated. We know that the FAA has received the information they felt necessary to support a Part 23 approval for airplanes, a Part 33 approval for piston engines, and that there's more underway for rotorcraft. So we do know that there's been recent reports of some materials, potential issues, and a lot of some work being looked at in terms of that fuel, but we only know what's been reported in the press and in the media related to that activity. The second fuel is the Swift Fuels 100R is the trade name. They also have received an engine and airplane STC. It is an initial engine and STC and an initial airplane STC with very, very limited scope. The Part 33 engine STC is only for the Lycoming IO360-L2A model engine. The airplane STC is only for Part 23 Cessna 172 Model R and Cessna 172 Model S. As with any multi-model STC or any AML STC, it starts with an initial approval, and then the applicant works with the FAA to expand it. GAMI did the same thing. They now have a very broad AML STC, but it initially started with an STC that was on just a couple make models, and then it grew from there with additional data and additional testing that GAMI provided as an applicant to the FAA. So Swift is going through that process today. They've announced that they've received those two STCs and on that limited scope. And they're continuing to work on expanding that with an AML STC to a broader scope, and then ultimately with a goal of a fleet-wide scope in supporting that project. Swift is also working with ASTM. They do have a task force established for a consensus process review of all the reports and the data that they're submitting for peer review through that process for the purpose of ultimately obtaining a production specification, which does help support the commercialization and the deployment of the fuel and the awareness and the understanding of the fuel by other stakeholders. So they are going through that traditional industry traditional process of obtaining an ASTM production specification for that. Swift Fuels also talked about limited availability and deployment of their fuel with targeted groups, Flight School and a couple others that are using their 100R on that scope of Cessna 172 RNS as part of their initial deployment in partnership with some operators, and will continue to work on their AML STC to expand that. So in terms of the Lyondell Basel VP Racing, they have a candidate fuel that they're developing, putting a lot of research and development into, like the other companies, but they are not a traditional aviation company. They're not somebody who has done FAA certification projects. They're not an organization that has made application to the FAA for any kind of an STC in the past. So they're pursuing the pathway that was made available under the fleet authorization. And that's exactly why that process exists, is to support the developers of fuel, to bring them in and invite them with a pathway to market to invest in development of something for general aviation. And so they're going through the PAFI program and the test program. Because we're involved as stakeholders in that program, we do have a lot more details on that. So we're going to go through that process a little bit to provide some understanding and visibility about that.
Yeah, so it is something, Walter. I'll give you a chance to grab a drink there. So we do have a lot more visibility into this. Again, this is the Lyondell Basel VP Racing UL 100E that is going through the fleet authorization process, which utilizes the Piston Aviation Fuels Initiative. So this is the program whereby the testing was defined by a collaborative effort through the manufacturer, the users, the community, to put the program together to determine what the envelope that needs to be tested to understand the parameters of the fuel. The testing itself is being done either by the FAA or overseen by the FAA as part of the PAFI program. So folks were wondering where the fuel is actually being tested. We'll show you here in a little bit where fuel is going out to and give you a lot more detail on this particular fuel.
Thank you, Rob. So in terms of the PAFI test program, as I said, that test program was developed in cooperation between stakeholders, primarily aircraft and engine OEMs, but other stakeholders involved in the aviation fuel process, and the FAA. And so there's some initial gates in terms of eligibility. We've had over 26 fuels have come into the PAFI program in the process over the years, go through some of those initial assessments and evaluations. Based on some of the experiences and lessons learned in that process, we've strengthened the program to try to do a quicker job at identifying critical characteristics in testing new candidate fuels that come in. So that's what the program is set up today. But on the flyEAGLE.org website, there is some background information on all the lessons learned, how the program has changed its testing methodology and its test program to be more efficient, to be more responsive to the needs of the fuel developers, to be able to bring a viable fuel forward. So the current fuel that's in has completed gates 1, 2, and 3. We call those the entry tests. Those are the mini materials compatibility, a very targeted engine performance and fuel property test, and a very targeted performance and detonation test, and a very targeted durability test. What we've done is we've identified what is the most critical fuels based on the composition of a fuel, or materials based on a composition of a fuel. What is the most critical engine from a detonation perspective and an engine performance perspective, based on just engineering judgment and assessment. And then did some very targeted tests to see how the fuel performs. Based on passing that test, it goes into a much bigger, much broader test program to generate all the data necessary to be fleet-wide. But what we're doing is we're trying to put the most challenging, most difficult outlier types of engines and aircraft and materials and test them up front to understand where the scope might be in terms of eligibility and applicability. So the current fuel, the Lyondell VP Racing fuel, has passed gates 1, 2, and 3 on those initial tests. We understand where those issues are, where the performance is. They are now in gate 4, which is full-scale PAFI testing. And we're going to do full-scale materials, performance and detonation, durability, some additional testing, and some aircraft testing. So this kind of has a summary and shows a percentage complete, but our next slide shows kind of a graphic representation of that really is telling in terms of the comprehensiveness and the scope of that evaluation and assessment. So in the category of detonation and performance on engines, so far we're just doing a process and how far we are, 32.2% of where it is today. But the most critical detonation engine, the IO 540K K1A5, has been completed. The TISO 520VB is just about complete. Those were the most critical to get through the first phase, couple of phases. But we're going to be testing the rest of the envelope. And that was determined, and you can see all the engine models there. That was determined based on a consensus approach of subject matter experts from all the engine OEMs, all the aircraft OEMs, a lot of the test labs and test experts out there who develop and design detonation measurement instruments and equipment, the analysis of that equipment and analysis of data for detonation testing, plus the FAA, and in particular the FAA Tech Center, who's the center that does a lot of the FAA's own independent detonation testing. So that's the envelope that was decided and defined for the purpose of a fleet authorization for PAFI. Likewise, below that, you can see the durability and performance. So that's where we take a lot of new components and constituents in these fuels. We don't know exactly what the performance might be when subjected to the extreme temperatures and the extreme limits of demands that are put on aircraft engines. So one of the certification tests is a 3349. It's a 150-hour endurance test. Plus, we added, as part of PAFI, an additional 200-hour flight duty cycles on top of that to ensure that if there's any longer-term effects of longer-term use under high performance situation, that we would have an understanding of that and then be able to address that accordingly. So you can see the list of engines that were identified to produce the data and the confidence necessary for the purpose of durability and performance of engines.
And Walter, there's been a lot of talk of materials compatibility here of late, so we should talk a little bit about that. And just so everybody knows, if you're trying to snap pictures of these slides are available on our Eagle website, flyEAGLE.org. Not only that, they're actually updated, and we're putting together an interactive portion on our website where you can go in and click on these different things, and it will take you in and list out a lot of what you're going to see here in a more interactive format. So you don't have to rush to take pictures. You're welcome if you'd like to, but all available at flyeagle.org.
So in the aircraft testing list, you can see all the aircraft that are part of that program. That is just starting just now. The one that you see is done 100%. That's because that is the fuel developer, LyondellBasell, entered into a contract directly to do testing of one particular aircraft that has a lot of instrumentation on it as part of their entry criteria. So that one is complete as part of their entry criteria. Now the full-scale testing being done on that list of aircraft, primarily done by the aircraft manufacturers. And then there's some additional testing on propeller vibrations, cold starting, fuel quantity gauging. There's different methods of fuel quantity gauging out there. And so we're testing across all those different types. But then materials compatibility. We do know that all of these high octane fuels under development have to include some new components, some new element to replace the detonation protection performance of lead. And those new components are introducing something different that we've never had in aviation fuel before. So from an aircraft perspective, one of the greatest areas that need to be evaluated and assessed is the potential of any materials compatibility. And when you look backwards to an entire fleet of over 200,000 airplanes, of just certified and uncertified and experimental aircraft, it's a very broad range of potential materials. So under the PAFI program, we've done as comprehensive an approach as we could in bringing together inputs from across all the manufacturers and from across the other stakeholders involved in the distribution chain to identify all of those materials that we think would be key contributors in having to assess. So as I mentioned earlier, all that data is generated. That data is then generated and feeds into the FAA determining an eligible fleet determination, feeds into the consensus standard process for an ASTM production spec. It also feeds into those areas where we do identify a potential impact. Say there's a material that we identify a potential impact. It feeds into one of the branches that Eagle has is to an R&D area of activity. If we identify anything in the fleet that might be impacted by one of the characteristics that we identify in a test for our fuel, we're then going to use that data to support an additional level of work to generate some kind of mitigation or solution. It might be a change in operational characteristic. It might be a change in material. It might be a coating that you put on certain materials, or it might be information to support an additive to be added to the fuel. But if there's an impact anywhere, that's part of the Eagle process and part of the PAFI test program is to feed into Now, understanding a potential impact, how do we address that?
And Walter, we talked about who actually is doing the testing, overseen by the FAA.
So I mentioned that we're just starting the aircraft full-scale testing. All of that testing is being done in-kind contribution by the different aircraft OEMs. So on the chart here, you see all the OEMs that are directly participating, plus the FAA's William J. Hughes Tech Center, plus Embry-Riddle Aeronautical University as a participant doing some work there, plus an air carrier, Cape Air, doing some of their commercial piston-powered airplane as part of their program. And then NRC Canada is actually doing the radial engine testing. Hartzell Propellers is doing the vibration testing. So you can see notionally, this shows how many gallons approximately for each of those tests and the scope and the size of the test, depending on how many aircraft that they're each testing. So this goes to show, that the extensive cooperation across industry with the FAA in conducting the testing and the support, but also the comprehensiveness of the test in terms of just the volume of fuel needed just to do the evaluation and assessment of these new fuels.
And Walter, we talked about materials compatibility. And again, all of these materials that we're going to throw up here, this entire list is available at flyEAGLE.org, but it highlights the extensive areas that we're looking at from a materials compatibility and the work that's actually being done. So you're seeing paint system. I also wanted to highlight for our amateur built community, a lot of these materials, a number of these materials are not necessarily found in production aircraft. They were added. The group that put together the testing actually includes a kit manufacturer, a number of kit manufacturers, as well as outreach to some of the other manufacturers of amateur built aircraft kits. So we're including that in there. So you see paint systems, fabric systems, hoses, bladders, O-rings. On this next one, the metallics, the non-metallics, a lot of OEM parts, finished parts. We also go through polysulfide sealants, a lot of our tank sealants, a lot of our different materials. So these are all being tested. Additionally, for our folks over in the distribution system. So we're including distribution hoses, linings for tanks, for trucks, filters, and coalescers that are found throughout the fuel distribution system as well. So again, remember the Eagle process, if you go back, a fuel had to work not only in the production, also the distribution in the aircraft as well. So this is the testing that's actually being done to be able to do that. And then for both in the production OEM side, the TC world and the non-TC world, type certificated world, a number of composites are actually being addressed as well. So a very extensive list. Again, I flashed through it pretty quick, flyeagle.org. It's going to be, it is available there in this format, and in the hopefully near future will actually be in a little bit more of an interactive form. But that's also where you can go to check on the testing itself. So we've got about 14 minutes left here. We're going to bring in Karen Huggard from NATA to talk a little bit about from the fixed base FBO and distribution perspective.
Good morning. I'm Karen Huggard, National Air Transportation Association. I am drinking a whole lot of espresso with some hot milk. I've got 5 shots in here. I make it every morning so that I am highly caffeinated and ready to go. So that'll help because I need to talk fast since we're running short on time. I'm going to go through this really quickly. I'm just going to give you a high-level overview of Eagle's work to identify and engage stakeholders throughout the avgas supply chain. All of this data that we're amassing through Eagle will be used to support a national coordinated transition to unleaded fuels. So we've identified and will be coordinating with more than 800,000 stakeholders in the following categories. 4 unleaded fuel producers, more than 15 general aviation fuel distributors, approximately 3,500 fixed-base operators, more than 600,000 general aviation pilots, and 250,000 aircraft mechanics. Together, these stakeholders will deploy unleaded fuels in a fleet of more than 230,000 GA aircraft, including both certificated aircraft and more than 30,000 experimental aircraft. Some of the key challenges we've already identified and will be working to solve include the lack of understanding about intermixability and fungibility of emerging fuels, both in fuel tanks as well as in the aircraft wing, maintaining 100 low lead access during the transition without having dual tankage available at most FBOs and airports. The increased risk of misfueling with multiple grades of fuel available on an airport, and premature actions by state and local governments that disregard the complexity of a national transition. For example, we had failed bans on 100 low lead attempted last year in California and Colorado, and we're hearing rumblings of similar state legislation on both coasts and in the middle of the country. So those are continuing to spread. Lastly, we have the vulnerability of the current fuel, 100 low lead, due to a single global producer of lead additive. So I'm going to now go to the perspective of NATA members. Sorry to fly through the supply chain stuff so quickly. NATA is the primary trade association representing fixed-based operators, general aviation fuel producers and distributors, Part 135 charter operators, and some 300,000 general aviation airports. So our members span all businesses across the supply chain from production of aviation fuel to end use. Our fuel distributor and FBO members are closely watching progress on these high octane fuels that are either approved or nearing approval. But we recognize that they need the necessary standards and protections for safe distribution of use. Each individual business is going to be considering multiple factors that will influence their decision to distribute or sell an emerging fuel. For fuel distributors, materials compatibility throughout the distribution supply chain has historically been provided through the ASTM International Standards process, as Walter and Rob have talked about earlier. ASTM uses a peer review process, and for our members, it evaluates the compatibility with materials throughout the supply chain upstream of the aircraft. That includes those used in hoses, filters, gaskets, and other wetted components in rail cars, transport trucks, fuel farms, fuel trucks, mobile refuelers, and other dispensing equipment. Just like aircraft owners need to have assurances that the use of a new fuel won't compromise the integrity of their aircraft or void their warranty, the same is true for our fuel distributor, airport, and FBO members who rely on ASTM specifications to minimize or eliminate the potential for degradation, contamination of the fuel itself, or the fueling equipment. In the absence of an industry consensus standard, establishing best practices and quality control standards for safe fuel storage and delivery is also a serious concern for our members. For FBOs and airports that sell fuels, additional factors that they're having to consider when they're making a business decision about whether to offer a new fuel is end user tolerance for potentially higher fuel prices, uncertainties about insurance coverage and liability risks, consistency of fuel supply to meet the demand on airport, as well as fuel tank limitations, as I mentioned earlier. These new fuels may be approved to be commingled with 100 low lead in the wing of the aircraft, but they must remain segregated in fuel tanks and trucks to assure safe delivery to aircraft based on STC limitations. As we look at the potential for multiple new fuels in the marketplace, misfueling risks are also going to increase. As Walter explained earlier, current testing of emerging fuel products has been done against 100 low lead, but now our members need assurances that all unleaded fuels that are emerging in the marketplace have been tested against each other for intermixability and fungibility in the supply chain and the wing of the aircraft. Some of those details are still not clear. Despite these challenges, NATA members are committed to ushering in an unleaded future in a way that's safe, coordinated, and commercially viable for both businesses and end users. In a few limited locations, as was mentioned earlier, California and now we're hearing in Mississippi, pilots and operators are experiencing new fuels in the marketplace in real time. NATA is closely watching the experience of those users to inform next steps toward the national transition. So I will turn it over to Murray now with AOPA.
All right. Thank you, Karen. So for pilots, owners, and mechanics, for that perspective, one thing really stands out, and that's the need for more transparency. Transparency of the testing protocols to gain knowledge for decision making that pilots, mechanics need and owners need to make. Provided a clear status of an unleaded fuel that's been fielded, to include issues that arise and what is being done to remedy them. Identify any gaps in aircraft that cannot use a specific fuel. If so, what is that gap? What aircraft modifications will be required to run a specific fuel? Misfueling, again, it's very high risk area. Mixing of new unleaded fuels that are not compatible. Limited tankage options. If 100 low lead is not available, leaving only a low octane fuel option. And 100 low lead must remain to ensure a safe and smart transition until an unleaded high octane fuel is reached a viable state. Complexity of the transition, you've heard a lot about, and you've seen a lot of the data that shows how complex this issue really is. Getting a fuel from the producer to the blender to the wing, working through issues that arise in testing and fielding a fuel, and getting transparency is paramount to success. As you've heard, there's two pathways that are FAA approved, and they both deserve continued support. Albeit there must be transparency for that to work. AOPA has often stated, if this was easy, it would have been done years ago, and that is so true. I know we're running low on time, so I'm going to turn it to Rob for an experimental amateur built look.
Yeah, and for the experimental amateur build community, Murray, it's important that we have information that ultimately it's up to each owner operator to make the determination that a new fuel is safe to use on their aircraft. That's the privilege that we get of flying experimental amateur build and the responsibility that comes with it. So much of the transparency that you talked about for each of these fuels is data and information that allows us to make that decision, make that transfer to the new fuel. So with that, Walter, 5 minutes to give the manufacturer's perspective, and then if we have any time, we can take a few questions.
Thank you, Rob. So I think when I talked about certification, that really is the core process for manufacturers in terms of ensuring and understanding the airworthiness and the safety. There's going to be a lot of big business decisions to be made by all the stakeholders directly involved in supporting, distributing, dispensing, and using a brand new fuel. And so it goes back to, I think, what both Karen and Murray highlighted is the importance of some transparency and understanding, because these organizations and businesses have big business decisions to make in terms of supporting the deployment of a brand new fuel, understanding what that fuel is, taking on business decisions for investment, business decisions for risks and liability, and their understanding of the fuel is what allows them to make those decisions and to support a brand new fuel. So for manufacturers, for example, there's been some coverage and understanding, well, wait a minute, if the FAA approves a fuel, what's this about whether or not the engine manufacturer approves a fuel or the aircraft manufacturer approves a fuel? The answer is yes. Every individual engine and manufacturer does issue their own acceptance of fuels. They do it first as part of the ASTM consensus standards process, and by participating in that peer review process, there's a collaboration and understanding across all the stakeholders, and ultimately they vote in support of a new production specification, and they vote and show their confidence and support for a fuel with their approval of that production specification. As individual manufacturers, they then also have to determine how they communicate to their owner operators and to their customers about their perspectives on using a new fuel. By having that understanding, they're able to do that. The additional thing is the manufacturers themselves will issue their own approval. So Lycoming has a service instruction where they publish their approved authorized fuels for their engines. Textron Lycoming does the same thing for Cirrus and Beech and so on for the other OEMs. Those are all how the manufacturers of engines and airplanes communicate to their customers that they not only endorse and support the fuel, but they can continue to provide continued airworthiness support. They can continue to provide warranty support for those engines and those airplanes that are modified by the owner operators to use a new fuel. And so that's why the manufacturers have a key role in understanding fuels and supporting the ability to support their customers. And then ultimately, when a new fuel is in the market, the manufacturers have to decide if they bring that fuel authorization into their own type design as part of producing a brand new engine and a brand new aircraft, and whether or not that new engine and that new aircraft will come out authorized to use a new fuel. Because when they do that, they take on all the responsibility of the airworthiness and the liability related to the use of that new fuel. So it's really important as another stakeholder in terms of being able to understand the performance of a fuel, understand how it might interact with their particular fleet and what was tested, what was evaluated, and what materials they have, and then providing support to their customers in the field.
Hey,
Right.
Walter, if I can, I think it's important too for the group to understand that below the OEMs then is the fuel distributors and the FBOs and airports that sell that fuel. And so the process that you just described that the OEMs are going to go through, the distributors and the resellers of that fuel are watching that same study and evaluation go on so that they can evaluate the risk and the complexities on how to address distributing those fuels to the end user.
Yeah. And I'll give you an example of just continued airworthiness support. So UL94 is a relatively new fuel, originally approved with an STC approval out there in the fleet, supported by all the stakeholders with an approved production specification for UL94, supported by most OEMs being approved in their own documentation for Lycoming engines or for aircraft manufacturers. And there's been a valve seat recession experience at University of North Dakota, and Lycoming is directly involved in doing the evaluation, the assessment, and determining what the causes might be and what the mitigations might be to understand how and why that's happening, because it's a little bit unique in terms of an experience. But they're supporting that continued operational safety. It's not their fuel, it's not their STC, but they're familiar with the fuel, they endorsed and supported it, they approved it, and now they're supporting the continued airworthiness for it.
So we are right up against, I think,